All right, so we will just still approach this week with the idea, down please, that tomorrow you're not going to be here, okay? Because you are scheduled to leave for Baltic. It just says a 1 o'clock. I think that's departure. So you probably will leave, or not even come to this class, and then is it softball and Baltic? I don't know if I think I just didn't see a time in there, so I just typically by default write 8 o'clock. So softball players, does that affect you for Baltic tomorrow?
That's a golf ball.
Yeah, softball isn't involved.
Okay. I could very well have wrote the wrong date down. I can see myself doing that. Okay. Okay. All right. All right. Let me. This isn't a debate or an argument. I just like to try to get the facts straight. Okay. Okay. Yes. Golf at Baltic, 8 o'clock tomorrow. So, with the presumption that golf is tomorrow and track, okay, that leaves a class size of 2, 4, 5, 6, 7, 8, 9. Does that sound correct? It just says golf at Baltic. It doesn't say it doesn't say if it's JV or not. Because on here, this is from Mr. Deitch from a long time ago. Usually it will say JV on it in junior high. So it's a presumption then that you'll probably be golfing in Renner tomorrow. Okay.
I don't think there's going to be much outdoor activity going on tomorrow.
Tomorrow's supposed to rain.
Well, yes, but I don't think that's scheduled till the afternoon. I don't know.
That's when it's supposed to hit.
That's right. So if you're starting at 8 o'clock in the morning, I think there's enough time that you probably will get started.
Get started.
The golf meet, though.
Golf, you probably go track meet.
Track meet, that's still up in the air. Correct. Okay, but the crystal ball is not working, so we have to go to the presumption that you are still going tomorrow. Yes. Okay. So that is May 1st, so there must be a rescheduled game. Okay.
Where?
Okay.
Right? Yeah. It's southwest.
Now, you don't have to write this down, and some of you have heard this before. If you know this today, you're going to know it tomorrow, you're going to know it the next day. This is just something to, let's say, something for your memory, to stimulate your memory, okay? Okay, then what other families might we write up here? Okay. Someone said benzene, that's right. But we would call them aromatics. That's fine. Okay.
Amino acids. Amino acids make proteins.
No glycine.
Okay. Now, just for family names only, what would we possibly be missing? There's about 4 more. Okay.
That's good.
Ether.
I was wrong. There was 6.
Aldehyde.
Still more.
Let me pull up my shack.
Of course, we could just write this down and then, but then our chances of remembering might go down.
Amine or mine?
Okay?
So it could be acid.
Okay? Still one more.
Acid.
Okay, now I think we've got everything pretty well.
That's all that's going to be on the test?
Yep, that's it.
But this starts to branch off into many different categories. Now,
Can I opt out?
for Thursday, no.
Semester test.
That's not optional. Okay. So, with, let's see here, these. Okay. Why might these have an asterisk next to them and these do not? Has something to naming. These are as well, but what we mean by this is perhaps you would see something like, let's see here. See here, it was methanol and what salicylic acid, I think, is what made your ester. That's a little too complex to put up here. But okay, so if it has an asterisk next to it, you're just identifying the organic family. It's not a ketone. That is an ester. Okay, so.
Just has the oxygen in the middle, right? Correct.
Okay, all I heard was oxygen in the middle.
Like ether just has the
Okay, so we want to change this to an ether. Then it could be as simple as that.
Okay.
Okay? Then, oh, I shouldn't maybe erase that. Of course, we know what that is.
That's alcohol.
It's an alcohol. That's a little tricky. That is an aldehyde. Typically, when we draw them, you're probably more familiar with that. Okay? But that means the same thing. Okay? There's your acid. That's right. There's your ketone. Okay. It's an alkane. There's an alkyne. Okay. So we have done every organic family except.
Wait, can you draw another aldehyde for us? Aldehyde is just a double bond oxygen.
Yes. You said what? Aldehyde?
Is the double bonded oxygen gonna always be on there?
With aldehydes, yes. Same with acids, but it has an OH group attached to it. Okay?
That's an amine.
That is an amine group. Yep. This is your amine group.
And what's the double bonded oxygen up top is
This one?
That's your aldehyde.
That's an
I
aldehyde.
know, but if it's a double bonded oxygen above the carbon, that's
Aldehydes.
no. But if you add another carbon,
This?
Oh, that's
This? No.
that's a ketone.
That's a ketone. Yep. Because the reason that we want you to get these organic families down, okay, especially for those of you who choose to be in here first hour next year, which, if I remember right, I think I only had about 5. I think. No, I got 9 wrote down in here. Okay. Well, we can take a peek really quick because we do have to do requisition, so it is important for that. And Mrs. Milbrandt will be arriving to your English class to talk to you about registration next year. Is that correct? Okay. So, but for my, my records, or for what will help me is these numbers. Okay, so now that we got that out of the way, now
Are you guys playing at the pedophile?
try again.
Denny Sanford, he's a pedo.
Maybe it's better off just
Keep those comments to yourself.
okay. Now, anything else about naming compounds?
Can we do a couple?
Okay. Let's see if you may fall into the same trap that we set for the freshmen. Sometimes they set or fall into it. If we have, let's start with hexane. Okay. We want you to put an ethyl group on there. And to do that, 2 carbons must be here then. Sometimes maybe it helps if we color code those. Okay, so there is our isomer that contains an ethyl group. No. How do you know? No. Oh, we still have 3-methylheptane then. So this isn't an isomer. No, it's not. Okay? So that must mean if we want our ethyl group to be on there, we need to put them over here. Okay? Oops. Then it doesn't matter whether you go up and over or just straight across. It's the same thing. Then just like every other time we want to make an isomer, just move on down the line. Okay, so let's do another one that has an ethyl group isomer. What's wrong with this? It's the same thing. That's right. There would only be one ethyl isomer. Okay. So let's see here. Let's put a stretch on here. And I don't know. There. Okay. Just like every other time, find your longest continuous chain. Oops. Hey, this will help. I'm going to put one more on there. That will really help out.
Isopropyl.
Isopropyl.
Okay.
2-methyl-4-isopropyl.
All right. So, for numbering purposes, we want the smallest number combination. So, in this case, it looks like it's 3 and 5, but which side are we going to start on? Because if we go left to right, it's 3 and 5. If we go right to left, it's 3 and 5. Why would we start with the isopropyl first? Right, because alphabetically speaking, this comes before that. Okay, even though this is a prefix, we disregard that prefix. Okay.
It doesn't matter what way you do it.
It does. The numbers are going to be the same.
Well, yeah.
Unless you didn't have the extra carbon, then it would be.
Oh, right. Yeah, then it could go up and over like that. Now, you might think, is that possible? Well, yeah. Some of these carbon chains, they can be bent like that, just because for any particular reason, some of the intermolecular forces in there can cause chains like this to take place. Okay? Anything else? Well, we said a couple examples. That was just one. Okay. These? Mm-hmm. That is correct.
So those would be the
Those are amino acids. That's right. Okay. So let's see here.
So when we draw them, are you gonna give us the thing? Like, are you gonna give us the, you know how you have those, what do you call those things? These deals where it's like the line and then you have the carbons?
I have to take it closer. Oh, okay. I thought we were still on the topic of amino acids. Oh, okay. So, yeah.
Like, how would you give it to us?
This is we've gone over this before, okay? This is tricky because if you look at that, you're going to draw a six-sided figure, and that's not right. Because if it's not a six-sided figure, it must be a what-sided figure? Okay? So then, what we want you to visualize happening here is okay, where is that carbon number 1 or is that one carbon number 1?
Left.
They both can be, but yes, but I think for our purposes, what would make the most sense, make this carbon number 1, which means this is just going to be an OH here, okay? Here's carbon 1, here's carbon 2, that's that one. Carbon 3 down here, it's on the left side, so what does that do to our OH molecule? Okay, then on this one, number 4, and then number 5. Yeah, there's a whole bunch of steps that go in between this, but this is good enough for our purposes.
So on the test, will you give us the stuff in the blue,
Yes,
and then we just have to draw that?
then you have to be able to do that. Now, which one?
That's gonna be,
Top.
Why are you right?
cause your, right side's on the top, or your left side's on the top. Right side's on the bottom. Or,
For this year, we said for our purposes, we'll go by saying this is our first, this is our second, okay? And since that's pointed up, it makes it that one. Yep.
so are you gonna tell us which one?
Yes, you would have to be told, draw beta D
Wait, would it change the other side?
this here?
Yeah.
No,
Okay. So
unless you're drawing the disaccharide. I originally planned on doing that, but I think,
yeah, can you draw the alpha right next to it?
okay.
Alpha? He's back here.
It's just that right side flipped, isn't it?
That must be what you said when we forgot one.
Yeah.
Okay.
Should those be flipped up?
Which one?
Should your OHs and stuff like the second carbon be flipped?
Which one? Are we talking about this one?
Yeah.
Okay. Where's carbon 1?
Oh, so it stays the same?
That determines that. Yes. Yep.
So it
Be-
just depends on your right. Right?
Yes. Like I said, the exception to that be is if we're going to draw sucrose, which means you're linking this up to a glucose molecule. But let's limit that to the biochemistry class next year. Okay? Even though you probably have that wrote down somewhere, the molecule sucrose, but we can disregard that. That's asking a little much. See, there again, maybe that's another application. We may be mean, but we'll give you a fair shake. Okay?
Appreciate it. Oh, that's a nice guy right there. You're a good man. You're a good man.
Okay. Anything else? Here at your disposal. Don't throw me away.
We're immune all week, aren't we?
Isn't that what that board says over there?
Yeah, for the most part.
Besides
Are we gonna have to do like the mothballs and the dyes and stuff?
Oh, you mean okay.
like vanilla and
Well, they're still up there. Okay. Good question. Because, okay, this is how we want to illustrate that this content builds upon one another. Okay. So what we mean by this, okay, just one. It's benzene. The moment we put two of them on there, even though it's not wrote over there, it's naphthalene. Oops. Okay, so what might be some uses for that naphthalene? Has something to do with smell. Okay. We get a little ahead of myself. Use these as a deterrent, perhaps. Okay. Then we'll color code these so we know we're talking about different compounds then. The moment we put another one on here, okay, now we've got this. Okay. So what about that? We say that's, you could say it's a reagent or catalyst for something like polyester, which when you think about those organic families we were talking about, polyesters, it's a whole repeating unit of esters, hence the name polyesters, which would affect yourself, you two, yourself, your John Deere, I suppose your Nike pullover, cardigan, or whatever that is. Is it Nike? It is Nike, isn't it? Okay. And then why are we avoiding everybody else? Well, could be, but because of their color. This is a reagent used for dyes. Okay. Used for this. Okay. Then now that might not be how it is in your book, but it's still the same thing as what we see over there. Say that again. Phenanthrene. Okay. So then, what's the concept behind?
Cigarette smoke.
Right. This is a carcinogen in cigarette smoke. So we can just do this. Yeah, just a little bit.
They're actually good for you.
All right. Anything else? Then them last three, those can get to be kind of tricky.
So we're gonna have to draw those last three.
Mm-hmm.
Is it only those,
Well, plus the naphthalene and phenanthrene and anthracene. Yes.
How many questions do you see on the test? Like,
Oh, enough. 25's too many.
Will we do like the toluene, phenol, and phenol?
Yep. That's correct. Now, one of the things, now that's a good question. The reason we bring that up is, to me, it's like taking advantage of opportunities. Like Minnesota playing baseball. Sometimes what happens is they lose to teams that they should not lose to. In other words, if you keep taking series, 2 out of 3, they went out to Anaheim and swept them over the weekend. And that's usually tough to do, going on the road and being a team in their own stadium and taking 3 games from them. Okay? So when you say are phenol and toluene going to be on there, take advantage of that. You're getting and obtaining points that we would hope and expect you to. It's like beating opponents that you should beat up on. Okay. Anything else? Otherwise, yes. Okay, that's all I have. We'll catch up to you next time.